Welcome back to the cave, everyone. This time it's Mom Bear that down for the count, so we're going to do this again. If you have not done a video lesson with me before, the rules are simple. A, you press pause whenever I say pause. Actually do it. B, when you're done doing the thing, you hit play and I'm here with the answers. That's it. Just like that catch and release in class. I pause, you do thing. After you're done, here I am with the answers. In the meantime, I'll just sit here awkwardly for about 3 seconds and then I'll keep going on about my business. Please make sure that if you have any questions and I have moved on past whatever it is, by all means, get on Remind and take a screenshot of whatever we're working on and send me a question. Otherwise, I hope to see you soon. We'll start with our daily quiz from 2.5, first half, graphing our rationals. Go ahead and pause it, get it. So, what we should have whenever we see a rational function is step one, we're going to factor. Factor, frickin' factor, right? We're going to turn this into x minus 3, x minus 1, over x minus 2, x plus 2. The zeros of my denominator are going to give me vertical asymptotes. So at plus and minus 2, I label x equals negative 2, x equals 2. The zeros of my numerator are going to get me vertical, or not vertical, x-intercepts. So I'm going to have an x-intercept at positive 3 and an x-intercept at positive 1. Now that should already look kind of funky because, well, wait a second. Like, why are they so far over to the right here? Shouldn't it be kind of symmetric? Zeros of denominator and numerator make vertical asymptotes, x-intercepts. Beyond that, if I were to put 0 in for f of x, so f of 0, this becomes 0, 0, 0. I get negative 3/4 as a y-intercept. So right about here. And then, to find out my horizontal asymptote, or sometimes oblique, I take the degrees. I go put them in my rules. Remember, the rules say whenever the degrees are the same, I'm going to have a horizontal asymptote at whatever my leading coefficients are as a fraction. In this case, y equals 1. Okay, so I've labeled all of that. I suppose over here I should also say x equals 1, x equals 3 as x-intercepts. Over here I've got my y-intercept, there's my labels. Okay, we're all good to go. So now I just need some more points. So, like, what am I doing with this? Is it going to snake up like this and maybe go through that asymptote? Is it, well, it almost looks like it might go through here. What do I do? Well, we go find some extra points on our calculator. And I just remembered that my computer does not have that, so we're going to pause and I'm going to bring up a graphing calculator. Okay, so as suspected, we go and grab that, and sure enough, we've got a little bit of a issue here where it's going to go through our horizontal asymptote, and that is now allowed because there is a solution between y equals 1 and that little cubic looking thing in there between the system of those two. So I need to head to my table. No, come on you. And we're going to plot a few more points. So I see 4 1/4. I see, and then it's going to get real close up against 1. Okay. Next up, I see at 1, 0. Yeah, I got that. 0, -3/4. Yeah, I got that. Also, the app is old, so all of my key press has to be a little bit off. -1, -8/3. I can work with that one. Down 3/3, 6/3, 8/3. Back up. 24/5 or almost 5. So 1, 2, 3, 1, 2, 3, 4, almost 5. 35/12, almost 3. So 1, 3. And I'd say at this point I've got enough to see the behavior of the graph. We'll go and fill that in, fill that in, and fill this in. There we go. So, our points. Do you have vertical asymptotes? Do you have horizontal asymptote? Do you have your X-intercepts? Again, whether you say them here or label them here, there's got to be a number somewhere. You can't just have dots. Do you have your Y-intercept? Again, you got the number somewhere. And finally, the general shape of it. Does it look decent? So, if you had any questions, again, remind, not just in class. If you had any questions from the homework, hit me up on Remind. Otherwise, we're going to just move straight on in where we left off. I got this in the wrong spot. Okay. So, we left off, there we go, talking about all the stuff up here where I have oblique asymptotes and sometimes holes. Now, if I remember right, we got through this one. Oh, no. Select tool, come on. Select tool, there we go. No, not you. There we go. I'm pretty sure we got through this one, but if not, I'm just going to turbo through it real quick, and we'll be good to go. So, I always factor whenever possible, and I turn this into 2x to the third over x plus 4x minus 3. My denominator turns into vertical asymptote, so at 1, 2, 3 positive, and at 1, 2, 3, 4 negative. I'm going to have, if I plug in a 0, f of 0 is 0. So we'll have a y-intercept of 0. If I try to set my numerator equal to 0, I get an x-intercept of also 0. Should make sense, it's the origin, right? And then I'm going to go find a oblique asymptote because the degree of my numerator is larger than the degree of my denominator. Now, okay, yes, we did do this one in class yesterday, but there was something I wanted to show you. So we did cubic divided by quadratic. See how we have two linear factors that make the quadratic? If I were to take something like 45 divided by 3, and then the resultant 15 divided by 5 to get 3. Isn't that the same as taking 45 divided by 15 to get 3? Right? So what I can do here, kind of cheat my way through it, is I can set 2 0x squared is 0x 0 constant, and I can divide by synthetically a -4 to -8, -8, 32, words. 32, negative 128. And then again with 3, 2, 3, 6, negative 2, negative 6, 28, no, 26, I'm tired. And then see how we're going to have double remainder here. If I divided longhand, didn't we have y equals 2x minus 2? So kind of the entire remainder mess doesn't matter. I'm still going to have this, oh god, that's right, this one's huge. And then y equals 2x minus 2 for an oblique asymptote. Okay, so, and I did not make my scale correct because I wasn't thinking here. I was thinking going by my normal 10 by 10 scale. This is 5 by 5. So it's going to look like this. And we had something like that in the middle. Okay, so that's what I wanted to show us. It is, I can do double synthetic with both of my denominator factors instead of longhand most of the time. Okay, there's some rare instances, but I would like you to, yep, that is where we left off. I want you to pause and do 4a and 4b from here, okay? Those two, 4a and 4b. Pause it, get it. Now, what you may or may not have done is, did you remember to do all of your x and y intercepts correctly? So here's what we're going to do. I'll put in some extra tick marks here so that this actually goes out to plus or minus 10. I should have thought of that ahead of time. Alright, set my denominator equal to 0 and get back here at negative 4 a vertical asymptote. If I plug in a 0, the function of 0 gets me negative 3/4, about here, as a y-intercept. Ooh, that's kind of blurry off to the side. When was the last time I focused this thing? Better? Oh, it's blurry off to the right. Good enough. And then we're going to do a little bit of division. We got 1, 3, negative 3, negative 4. Do your synthetic, right? Negative 4, negative 1, 4, 1. And again, I don't care about my remainder. I have y equals x minus 1 as an oblique asymptote. So negative 1 is here, slope of 1. Down 1, back 1, down 1, back 1, down 1, back 1, down 1, back 1. Okay. With every one of these tick boxes, remember these are going by 2s basically. I got my hash marks there. Okay. Did you remember to find your x-intercepts correctly? See, that numerator, not factorable. But if I real quick do x squared plus 3x equals 3, set up 4, complete the square. Half of 3 is 3 halves. 3 halves squared is 9/4. 3 plus 9/4, or 12/4 plus 9/4, is 21/4. Always x plus b over 2, the quantity squared, if I factor my perfect square trinomial. And now I have x-intercepts at negative 3 halves plus or minus the root of 21 over 2. And I got to this with one of you. Can't remember if it was first or second hour. Now, you could have done this by quadratic formula, but either way you have to solve the numerator. And when you do, this is the correct answer, but how do I plot it? Well, that's where the decimal approximation comes in. I'm going to label them correctly, but the decimal approximation is going to be good enough to put a dot on the paper. So square root of 21 is about 4.6-ish. Divided by 2 is 2.3-ish. So negative 1.5 plus 2.3 is about 0.8. Negative 1.5 minus 2.3 is about negative 3.8. So 1, 2, 3.8. Okay. Now you see these 2 points, I can also use my symmetry from here. It was up 1, 2, 3, 4, 5 over 0.2. So from here I could go down 1, 2, 3, 4, 5 over about 0.2. This was up that 5 over 1, 2, 3, 4, 0.8-ish. So I can also go down the 5 and over the 4.8-ish from that point. So right about there. Again, go find another point here on the calculator. I'm going to trust that you did that because I hear children coughing and I need to speed this up. Okay. Round 2. I am again going to set this equal to 0, and at 3/2, 5. Yeah, I gotta go again by 1, 2, 3, 4, 6, 7, 8, 9, 10. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because I don't know how big this thing's going to get. I'm just winging it. Okay. I literally just put a grid on the paper and we're going for it. Alright. I'm going to have a vertical asymptote at positive 3/2. So 1.5 is about, label X is 3/2. Oh, and by the way, I know that it says find the domain for all of these. No, you're not getting brownie points for that. I'm going to put in 0 for all this. F of 0 gets me negative 1/3. And first hour's brownies are sitting out on my stove, so they're just going to sit there. Put negative 1/3 as a y-intercept. And when I go to find my x-intercepts, again, this is not factorable. So x squared minus 4x, I'm going to subtract 1 to the other side. Half of b, negative 2, squared 4 to both sides. It's always x plus b over 2, so in this case, minus 2. The quantity squared is 3. Solve by square roots. X is, I'll have to add my 2 over, plus or minus square root of 3. So I'll have x-intercepts at 2 plus or minus about 1.73. So at 1, 2, 3.73, and at about 0.261-ish. So there's x-intercepts. So you see how these two are real tight together. I haven't even finished the problem, and because they're so tight together and there's one on the other side of that vertical asymptote, I'm betting it's going to curve upward right here. And that's something you just get used to over time, the more of these you do. Next, I need to find what my oblique asymptote is. I'm going to do that with synthetic division because I have divide by a linear. 3 halves into 1, negative 4, 1. Half of 1 is, well, a half, times 3 is 3 halves. Negative 4, or negative 8 halves, plus 3 halves is negative 5 halves. And then remainder. So we might think this is x minus 5 halves. But remember, that's why we spent all this time about the difference between finding zeros versus finding factors. If I were to do this long division, I would not be dividing by x minus 3 halves. I would be dividing by 2x minus 3. So I need to take this and also cut that down. Divide these by 2. 1/2 x minus 5 fourths. Okay, so negative 5 fourths, or just past 1, up 1 over 2. Up 1 over 2. Up 1 over 2. Or down 1 back 2. And I see an oblique asymptote right here. And you see that little curve right there? You see that point right next to the asymptote? Again, we're going to be curved in real tight against them. Like so. Okay? Again, you can go get your graphing calculator and double check that. So, on to example 5. Kind of the same thing. Here, poke, poke, there we go. Example 5 starts with, well, it looks like it's all going to be the same, but this is where we start getting the holes. See, we said we're always going to factor. The reason I'm always going to factor is because sometimes x plus 2, x minus 4, like this, I get a removable factor. So graphing them is actually really easy. You just graph what's left. What's left tells me at 1, 2, 3, 4, I have a vertical asymptote, zeros of denominator. At 2, I've got an X-Intercepts. If I plug in a 0, I'll get 1/2 as a y-intercept. And degrees are the same, so leading coefficients are 1 over 1. I got a horizontal asymptote at 1. So I graph what's left. This is the thing that I graph. See how I only have single vertical and horizontal asymptotes? I can use those chess move, those knight piece L shapes of left 2 down 1 means right 2 up 1. Left 4 down 1/2, right 4 up 1/2. If this is left 2 down 1, then I can go left 1 down 2. I can reverse it. Likewise here. So I get these extra points. The difference is, because I removed this, that means x does not equal -2. So back here at -2, I'm going to have a hole. And I can find out exactly where it is by putting 2 into what's left. See, if I graph what's left, there should be a point here, and I can find out exactly what it is. If I put -2 in here, I'll get -4 over -6 is 2/3. So the point -2 2/3 is the one that's removed. Because if -2 was allowed, then it should have existed at 2/3. But it didn't. So I put a hole. So back here at -2 2/3, and then connect the dots. And there's your graph. Okay, so graphing the ones that have holes is actually really easy. You follow all the same rules. It's just you got to put the hole. Remember, the calculator will not show it. You have to know where it is. So, if you would, pause it and go get 5a and 5b. And yes, I know I'm supposed to find the domain. I'm not going to find the domain because I don't want to, because I'm petty. Go. Oh. Okay. What we should have is x plus 4x plus 6 over x plus 4, x minus 3. We should have x minus 3, x plus 1, x minus 5, x plus 1, and removable factor. Removable factor means you're going to have a hole at x equals -4, a hole at x equals -1, and then graph what's left. Vertical asymptote, x equals 3. X-intercept, +6. Ooh. I probably should have made these bigger again. If I put in 0 for both my x's, we get 6 over -3, so a y-intercept of -2. It's making me really nervous. I can hear one of my boys on the monitor over there. And the degrees are the same here and here. So leading coefficient over leading coefficient. Horizontal asymptote at y equals 1. So I will come along and plot some more points. See that symmetry again, those little L shapes. Right 3, down 1 means I will go right 1, down 3. Oh, wait a second. X-intercept there, but a y-intercept there. Maybe something weird is happening here. X-intercept of, oh wait, it's a -6. 1, 2, 3, 4, 5, 6. Because it's just been a freaking day and a half. Okay. Like literally, for those of you who weren't paying attention, to remind, I had to leave earlier. I didn't even make it to Spartan time, had to come rushing home. So those don't exist. Be kind. No brownie points. Left 3, down 3 means I can also go right 3, up 3. That's more like it. This one says back, oh Jesus, 9, down 1. If I had enough room, I would go right 9. 1, 2, 3, 4, 5, 7, 8, 9, up 1. I kind of don't want to do that because it's in the next graph. But you see the big womp and the big over to there. Okay, so just your graph will be prettier. Difference is back at -4. So 1, 2, 3, 4, we're going to have a hole. And if I were to put a -4 in here and here, I would get 2 over -7. So this point is at -4, -2/7. Okay. Same over here, but hopefully we won't screw it up that bad because negatives exist. We're going to have a vertical asymptote at 5. I'm going to go by 2's this time. So 2, 4, 5. We're going to have an X-intercept at 3, 2, 3. I'm going to plug in 0 for X, get positive 3/5. So about there. And degrees are the same. Leading coefficients 1 over 1. Got a horizontal asymptote. I use these steps again. This says from that intersection, that crosshairs, I went left 2, down 1. So I can also go left 1, down 2. I can also go right 1, up 2, or right 2, up 1. And you can see that curve again. But I have to be careful that there's a hole at x equals -1. If I put -1 into what's left, -1 minus 3 is -4. -1 minus 5 is -6. So I will have a hole at -1, positive 2/3. I just make that little open circle to say, hey, there's a hole here. And there we go. Okay, so graph everything that you've been graphing. Just watch out for holes. Okay, you don't get it as much around spearfish, but around the Midwest, particularly North Dakota, Minnesota, Iowa, insert joke about potholes here. So moving on to, again, if you have any questions about any of the graphing thing, just hit me up on Remind. I go to example 6 and I wonder, why is this in a PreCalc textbook? Because these problems are from algebra half. I kid you not. Algebra half. Like, this is just solve an equation. Well, maybe algebra 1, chapter 9. But blah blah blah, solve. Well, see how there's only 2 terms and a 0 on the other side? Easiest way to deal with that is to subtract either one of them to the other side. For the ease of it, I'll leave this here and subtract x to the other side. I turn it into a fraction, cross multiply solve. Okay, so algebra 1, not half. Negative x times this stuff, if I distribute, is negative x squared plus 8x. 6 times 1 is 6. Oh, hey, look, it's a quadratic. Everyone to one side of the bus and solve. X squared minus 8x plus 6. Factors of 6 add up to -8. Don't exist. Did I do this right? I thought it was easier than that. Right? Subtract x. 5 negative x alpha. Positive x 6. Same shoot. Yeah, okay. Since it's not factorable, I'm going to go to complete the square, and I'm going to keep forcing complete the square on you. Turning that into x squared minus 8x equals -6. So I'll move the 6 back over. Half of negative 8 is negative 4. Negative 4 squared is 16. Add 16 to both sides. Getting the quantity x minus 4, always half of b squared, is 10. Solve by square roots. Getting x is plus or minus square root of 10, and then I'll have to add 4 over. So 4 plus or minus square root of 10 as an answer. Just get part of it on one side, part of it on the other, cross multiply, solve. Okay? So those two, let's see if you remember Algebra 1. Pause it, go. Okay, here we should have 20 over x plus 3 is 4. This one's way easier because you don't even end up with a quadratic. When I cross multiply, I'm going to get 4x plus 12 is 20. Subtract 12 is 8, divide by 4, x is 2. Done. For this guy, I'm already set up for my cross multiply. Shoop, shoop. Getting 6x minus 12 is 9x, but this time again, no quadratic. Subtract 6x, divide. Now, what I want you to just slowly roll about, double check these. Are those legal? Did you even check? Okay, my original equations have x on a denominator. So just like when we were dealing with our radicals, my original equation had a square root. I needed to check for extraneous. My original equation has x on denominator, got to check for extraneous. I'm tired. Both of those, these work, okay? It's just, you have to check them. So, let's go on to example 7 where we got a little more meat and potatoes. Okay, with example 7, these we did in Algebra 1. This was Chapter 9, and this is why a lot of freshmen get really hurt in Chapter 9. And we moved it up to Algebra 2. Is you have to be able to factor and factor very well. Anyway. But I can't add these two things together unless I remember basic fractions. See, if I said 1/2 plus 3/5, I can't do that until I multiply by 5, by 5, by 2, by 2, and turn it into 5/10 plus 6/10, because now they share a denominator. Common denominators to add together fractions. Now, what you can't say, do not do this. I can't subtract 2 and subtract 2. Say, well, now it's x minus 4. Factors. This is using sums. Don't you dare do that. That is freshman math and a half. Bad. Instead, I see that this has a denominator of x minus 2 and a denominator of x minus 4, just like 2 and 5 here. I need to multiply them by each other. So this is missing a x minus 4, and whatever you do to the denominator, you do to the numerator. Whatever you do to the denominator, missing x minus 2, you do to the numerator. Okay. Now, if I were to factor this guy, notice it's the same set of factors we have over here. So what would happen if I had a bunch of junk over 5 plus a bunch of junk over 5 plus a bunch of junk over 5, and I multiply them all by 5? my denominator goes away. So if I take all of this, now that they all share that denominator, and multiply them by that quadratic, x squared minus 6x plus 8, what it does is just skadoosh. Gets rid of all of them. They'll all cancel out. Leaving me with 4 equals, distribute, 3x squared minus 12x, distribute, plus 2x minus 4. You just get a quadratic. So go solve your quadratic. Subtract 4 over, combine like terms. 3x squared minus 10x minus 8. Set an equal to 0 and solve. In this case, it happens to be factorable. If you need to go full AC method on it, factors of negative 24 that add up to negative 10. 3x squared minus 12x plus 2x minus 8. Cut it in half. These have 3x in common, leaving x minus 4. These have a 2 in common, leaving x minus 4. Or are you able to go from here directly to, well, this is prime. The only way I'm going to get that is with a 3x and an x. Mental math mojo your way through some factors of negative 8 until you get x minus 4 and 3x plus 2. Set equal to 0 and solve. X is negative 2/3 and 4. Or is it? Because look back at your original problem. Homie, don't play that. See, that negative or that 4 is not allowed. It's extraneous because my original equation has x on denominator. I have to double check my answers to make sure that they actually work. So you get common denominators, multiply everything by that quadratic if it happens to be the same, distribute on your numerator, you got a quadratic to solve, double check your answers. So you pause it and give those a whirl. Okay, kind of regretting bringing this one down too far. Here, I'm missing x minus 6. Here I'm missing x plus 3. This happens to factor into x minus 6, x plus 3. So, if I were to multiply the whole honkin' thing by that quadratic, my denominator is now going to peace out. And I'm left with 2x squared minus 12x, distribute, 3x plus 9 equals 27. Another quadratic to solve. Everyone to one side of the bus. 2x squared minus 9x minus 18, 0. The only way I'm going to get 2x squared is with a 2x and an x. Can you mental math your way through factors of negative 18 to get here? Okay. I haven't slept more than 5 hours in the last 17 days. I think you can do it. I believe in you. Getting x is negative 3/2 and 6. Or is it? Again, 6 isn't allowed. It's extraneous. Do it again. This guy is missing just an x. This guy is missing a x plus 6. again, if I multiply the whole honkin' thing by x squared plus 6x, then all that denominator goes away, leaving me with, careful, that negative is still there. Negative 12 is 2x plus distribute, FOIL, whatever you, oh yeah, you were in the class that didn't know what FOIL was. Distribute, FOIL, whatever you want to call it, x squared, x times 6, 6x, negative 2 times x, negative 2 times 6. You got a quadratic again. Put everyone on one side of the bus, getting x squared, 2x minus 2x cancels, plus 6x. Negative 12, add 12, I get 0. Huh. How do I solve a quadratic that doesn't have a c term? You'd be amazed how many times in PreCalc kid will just brain fart on that one. Take out your GCF. Set each equal to 0, x equals 0, and negative 6. But look at your denominators. Neither of those is allowed. So sometimes you do all the work correct, and there's still no solution. Okay, so if you need the practice, you know what, I take it back, do the practice. On the next page, sorry, I forgot to zoom in on these as we were working. Flip it over. I think 6, 7, 8, you're going to be fine. I'd like you to get just one more round of it with number 9. Go ahead and pause and do it one more time. Something that I've seen before, and kids get caught in this trap, is what if this was 2p over p plus 1 minus 3 over 1 minus p. Okay, I'll stare at it for a second. You see it's the same thing? If I take this times a negative 1, I get negative 3. If I take my denominator times negative 1, it changes both signs into 1 minus p. And I'll see kids who get caught in that trap, that this is p plus 1, p minus 1, and they'll just kind of think, close enough, and they'll just run with it, pretending that this is just p minus 1, and they'll take this times p plus 1, and just go. Not the case. Be aware of that. What I would do is plus a negative. I would recognize this isn't the way that I want it to be, so then I would just change all the signs, because that's the same as multiplying by negative 1 over negative 1 to get this. So a little bit of a tangent there, but it's come up before, and I don't want you to get caught in that trap. Take this by p minus 1, it's what's missing. Take this by p plus 1, that's what's missing. And this guy, as we said, factors nicely. If I multiply the whole honkin' thing by p squared minus 1, this will all cancel, getting me a 2p squared minus 2p plus 3p plus 3 is 15 minus p. And now you get the kid who really has to use a bathroom, like, stop saying big. Everyone on one side of the bus, 2p squared. Negative 2p plus 3p is just p. Plus another p is 2p. 3 minus 15 is negative 12. Make your life easier. Take out 2, getting p squared plus p minus 6 is 0. Factors of negative 6 add up to positive 1 are p plus 3, p minus 2. Getting p is negative 3 and 2. Double check. They are legal. Both are your answer. Okay, and one last thing is just words. Sometimes they're going to give you a word problem context where it's just blah, 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 do the same thing. Okay? It's just an example of where rational functions may be used. So you have a parallel resistor circuit. If any of you have ever done the CAD class, I think, who else? Band's got a DC electronics class that usually happens every other year. So maybe you've seen this before. But definitely you'll see them in physics. You have a series of resistors. The equivalent resistance for the entire honkin' thing is given by the sum of the reciprocals. The reciprocal of a resistance is the reciprocal of all the other resistances added together. No, you cannot just swamp the whole thing. You cannot just flip the whole thing upside down and say, well, isn't that just all of that, but over ones? No, you can't do that. Because these are sums, not products. I can't just reciprocal. They give me a little bit of just substitution stuff. They say R sub 1 is twice R sub 2. Okay, got it. 2 R sub 2s. They say R sub 3 is just straight up 20 ohms. Okay. And big R, the total resistance, or equivalent resistance, is 10. So you see that even though there was a whole bunch of R's and they had subscripts to mean different ones, it's just the same variable again. This might as well just be an X. In fact, if you wanted to kind of copy our U method to say R sub 2 is X, to rewrite as 1 over 10 is 1 over 2x plus 1 over x plus 1 over 20, because that just makes you feel more comfortable. Then go right ahead. I still need common denominators. So the least common multiple between 2x, x, and 20 is going to be 20x. So this guy is missing a 10. Now 20x. This guy is missing a 20. Now 20x. This guy is missing an x. Now a 20x. While I'm at it, so I can do that whole knock out the denominator thing, I'm also going to multiply this guy by 2x. See, now they all have a denominator of 20x. So take the whole thing times 20x and they will skadoosh. Getting 2x is 10 plus 20 plus x. Subtract x. Combine like terms, x is 30. Now that's R sub 2. If r sub 2 is 30, I still need to go back and find what all of them are. This may be 30, but it said r sub 1 is twice that. So there's 60 ohms. They told me this one was 20, and this one was 10. So now I know the resistance of all of the different circuits, or all the different resistors. So it's just an example of I can use these. I can use a rational equation if I have to. So scrolling on down, it's going to be the same business, except now it's a different formula. So blah, 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 blah. Says I is current, T is time. What time or times are there when my current is 1? So replace I with 1 and have at it. So we'll have 1 is T plus 1 over 10 minus T. And you see getting common denominators should be fairly quick this time. 10 minus T times 10 minus T over 10 minus T. Now they all have common denominators. Multiply the whole business by 10 minus T and skadoosh. 1 times a thing is just that thing. T times the stuff is 10T minus T squared, and that's just a 1. It's a quadratic. Everyone on one side of the bus, solve the quadratic. Getting T squared, subtract 10T, getting negative 11T, subtract 1, getting, 9. So close. If it would have been 10, yeah, you would have had negative 10, negative 1. It just didn't quite make it there. So we're going to have to go to quadratic formula or complete the square. I'm going to keep banging the drum on complete the square. We'll call that T squared minus 11T is negative 9. Half of negative 11 is negative 11 halves. Negative 11 halves squared is 121/4. You're like, why are you doing this to us? Because it's easier. It really is. T minus 11 halves, because it's always b over 2, is how I take a perfect square trinomial down to a binomial squared. Negative 9 plus 121/4. Take this times 4 over 4. This is a negative 36/4 plus 121/4 is 15 to 5, 85/4. I hope I've been doing my mental math right this whole time. And then when I solve by square roots, I get T minus 11 halves is plus or minus. When I square root a fraction, I square root its parts. I'll get the square root of 85 over regular 2, which means I don't have to go rationalizing anything. And then move that over. We'll have T is 11 halves plus or minus square root of 85 over 2. Now I want to double check that, because where's my other calculator here? Okay, come on, there we go. All right. Yeah, you can see my the reflection of my LEDs under there. I'm going to take 11 halves plus root 85 over 2. Okay. First of all, these calculators are great because they'll simplify radicals for you. But I want to double check that this actually works. About 10.11 seconds. Negative. There we go. Okay, 0.89 seconds. I wanted to be careful about that because, yes, this is the correct answer. This is the perfect answer. But I want to check that I didn't end up with a negative time, because then that wouldn't make sense, and I would again have an extraneous solution. So, there it is. We did daily quiz, example 4. 5 was the holes instead of oblique. 6 was old school. 7 was do a bunch of common denominator stuff to solve equations. And 8 was word problems. Sorry for being gone, but it's hard to describe our current situation without the word cluster. So, I hope to see you soon. Please use Remind and ask questions.